In central Texas, an ordinary stretch of limestone country was hiding a very unusual prehistoric record. Researchers explored it the hard way, crawling and snorkeling through an underground stream. That record was found inside Bender's Cave, a real water cave in Comal County. Many of the fossils were not buried deep in rock. They were lying on the cave floor.
One of the most striking finds was a giant tortoise, an animal that points toward warmer conditions.
The cave also held evidence of giant ground sloths, animals more consistent with a richer, more wooded habitat. Researchers also identified a pampathere, an armored relative of the armadillo, roughly the size of a lion.
Among the other finds were saber-tooth cats, adding to a faunal mix far broader than most viewers would expect beneath modern Texas. Camels and mastodons were part of the picture too, suggesting a landscape very different from the Texas most people imagine.
The fossils do not appear to represent a single dramatic event. They were likely swept into the cave over time through sinkholes, erosion, and flooding. Many of the bones were rounded and polished, signs that water had moved them before they came to rest here.
Each find had to be collected and examined carefully, piece by piece, inside a cramped water cave.
The site was important for another reason too. It was described as the first paleontological study of a Texas water cave. Together, the giant tortoise and the pampathere point toward a warmer version of central Texas. The ground sloth and mastodon suggest something else as well: more woodland and a more complex habitat. During colder glacial periods, central Texas appears to have been more open, drier, and grassland dominated. Taken together, the site may preserve evidence of an older, warmer interval in Texas prehistory, possibly around the last interglacial. But the age of the site is not locked down with complete certainty, and the interpretation has to stay careful. What the cave offers is not a perfect snapshot. It is a partial record, shaped by water, time, and chance. Beneath a landscape people know well, this cave may have preserved a very different Texas from the one we see today.
On the surface, the hill country looks ordinary, but limestone terrain like this can funnel water, sediment, and debris into hidden passages below.
Over long stretches of time, water moving through sinkholes and fractures could carry material down into the cave system.
Inside the cave, moving water would have sorted that material, carrying some fragments onward and leaving others behind. What remained was an underwater fossil lag, a collection shaped by transport and accumulation rather than a single moment frozen in place. The site was studied over multiple trips, with researchers surveying different parts of the cave in search of more evidence. That is part of what makes the discovery so striking. Above ground, almost nothing hints at what the cave preserved below.
If the interpretation is right, central Texas may once have supported a warmer ecosystem than the later glacial picture most people know. By contrast, younger glacial intervals in the region are better known for more open grassland conditions. It is the combination of these animals that matters most. Together, they make the warmer climate interpretation more persuasive.
What makes the site powerful is not just what was found, but what it suggests about a Texas landscape that no longer exists.
A warmer ancient Texas would not have looked like a jungle, but it may have been more wooded and more humid and more diverse than the later glacial landscape. The animal mix suggests a habitat mosaic, with open ground in some places and more woodland in others.
That is what gives the cave its scientific value. It is not just a single fossil find, but a concentrated record of a broader ecosystem. In this regional context, finding this combination of animals together is what makes the cave so unusual. Caves like this do not preserve the past by accident. They act as hidden filters, drawing material inward through the landscape over time. Many of the pieces share similar mineral staining, another clue that they may have passed through the same underground process.
That also means not every bone had to arrive at the same moment. The deposit may represent accumulated time.
This is why the strongest version of the story is also the most careful one. The cave offers evidence, but it still leaves questions open.
That makes the cave less like a single snapshot and more like a compressed archive, hidden beneath an ordinary landscape. Even as a partial record, Bender's Cave may be enough to reopen the story of how ancient Texas once looked and who lived there.
The researchers think the cave may preserve evidence from an older warm interval, possibly around the last interglacial.
But the cave does not offer perfect dating evidence, so the interpretation has to remain careful.
What survives here is not a full snapshot of one day in prehistory. It is a filtered and incomplete record. That is why the site is better understood as an accumulated fossil lag than as a single dramatic graveyard. Its significance comes partly from contrast, an ordinary landscape above and an unexpected record of lost ecosystems below.
If this interpretation holds, Bender's Cave may help fill in a warmer and less familiar chapter of Central Texas history.
That matters because the better-known younger glacial record in the region tends to point toward a more open grassland world. It is the combined signal from the tortoise, pampathere, and other animals that makes the warmer climate case more compelling.
For scientists, discoveries like this do not end with the find itself. They begin a longer process of interpretation.
What Bender's Cave offers is not the last word on ancient Texas, but a rare and valuable piece of the story. That alone makes the site notable. It has been described as the first paleontological study of a Texas water cave.
That is part of the discovery's power. Nothing about the surface announces the record hidden below.
The more the fossil list expands, the more the cave begins to read like a compressed record of an entire ecosystem.
If the cave really reflects a warmer interval, then ancient Central Texas may have supported a richer and more varied habitat than the later glacial record suggests.
That contrast matters. Later glacial Texas appears more open and drier, making the Bender's Cave assemblage stand out even more.
Sites like this do not speak in complete sentences. They offer fragments, patterns, and clues that have to be read carefully. Most of that ancient world is gone. What remains here is only a fragment, but it may be a fragment that matters.
And if this cave is telling the story researchers think it is, then some of ancient Texas disappeared long before anyone knew it had ever been here.
That may be the most powerful part of the discovery. A place that looks ordinary today can still preserve traces of a vanished world.
Bender's Cave does not give us a complete picture, but it may preserve one of the missing pieces.
In the end, the whole story comes back to evidence. Fragments of bone, moved by water, waiting in the dark.
If the interpretation is right, then this familiar part of Texas once held a very different living world. And beneath these familiar Texas hills, a lost chapter of the Ice Age may have survived in silence.
For more real hidden world discoveries told through evidence, subscribe and follow along. There is still a lot beneath familiar ground that we do not fully understand.